My name is Matthias Sandling. I'm an evangelist and Mythbusters at Quest Software.
And I'm Eric Sloef, and I'm a VMware certified instructor, and I'm running a website called ntpro.nl, and I'm well known for posting scoops on my website. So we are going to present Mythbusters Goes Virtual.
And unfortunately, we didn't have the budget that these guys have, but we're trying to make it as interesting as possible. We're going to try to miss some busters today.
I would love to have the tools those two guys have. They do all the awesome stuff with explosions and crash test dummies. And we asked Scott Harrod, but he wasn't available for crash test dummy. But in the end, we're just two virtualization guys, and we want to do some myth busting on our own. So we figured, why don't we do the myth busting in our own lab environment and try to bust some myths that are floating around. And you saw some myth floating around, Matthias.
Yeah, it all started on Twitter and social media, and as my role at Quest, I also speak to lots of customers and partners. So we collected a couple of those and put it in the test labs.
You really were teasing me, Matthias. On a Saturday night, 10 o'clock, I was ready to go to watch some TV, and Matthias is, isn't it true that raw device mappings are faster than a plain VMDK on a VMFS? And that's something like, no! And then it started. Then the idea of our session was eventually born. Yep. So what are we going to do?
Yeah, first I want to give you an introduction to this session, and this is also the key takeaway. And it's that vSphere evolves with every release. You have seen vSphere 5 here at this show and probably prior to the event as well. And with every release, there are new features, things change. So with that, you have to adapt to the new things that is occurring. So things that used to be true aren't true anymore. And last but not least, I would encourage you all to engage in different virtualization communities. The VMAX is an awesome place to meet up with similar people, the VMTN network to ask questions, get help from others. There's many blogs out there.
They're books.
Yeah. Duncan Epping and Frank Denman's book here is a great example of something that takes time to capture that, and lots of great books and blogs out there. Then there's also Twitter. Most people here might be using it. People that are not using Twitter, that's something that you can use to follow people in the virtualization space, get up to speed. If something nasty is about happening, you can stay up to speed on almost everything. So really encourage that. So the myths that we have put in the labs here for this session, the first one is that Eric mentioned, that raw device mappings, do they actually have better performance than regular VMFS? Secondly, about change block tracking, that causes significant overhead on virtual machines. And this is something that has never been documented, so I'm most a little bit curious if the reason for that is if it's actually can cause performance degradation on the VMs. And then we're going to talk about resource pools. I've heard some other people talk about them. If it's a good idea to use them as allocating resources and also use them as a way of categorizing VMs. And finally, we're going to look at the LSI SCSI controller and compare it to the paravirtualized SCSI controller to see who's the better one. So with that said,
yes, let's start
Eric.
with the first myth. So I want to ask you guys, who is still using RDMs, raw device mappings, in their production environment? Can you? Okay. 10%, 20%. So are you using them because they are faster, or do you have other use cases for them, like you want to configure your SAN, or you have a very large amount of data on your environment, on your SAN, and you don't want to put all the data in a VMDK? Is it for speed, or is it for another reason? I want to see some hands for speed. Oh, nobody. I'm going to have a tough time.
A couple of hands.
A couple of hands.
Yeah.
Okay, so let's take a look at the fact that iSCSI raw device mappings have superior performance over VMFS. That should be true. I think so. So what's a raw device mapping in the first place? When you are configuring a virtual machine with a virtual disk, then the virtual disk will be connected to a symbolic link. A raw device mapping is nothing more than a simple symbolic link. And once the virtual machine accesses the virtual disk that is pointing to a symbolic link, the virtual machine will get access to a raw LUN. Doesn't sound that cool. So something raw must be fast. Raw. Can you say it? Raw? Raw. I don't hear anything. Raw, yeah. Raw must be fast. So the virtual machine, the disk, doesn't have to go through the raw device mapping anymore. It's connected to a raw LAN and it must be fast. So is it really faster? And let's take a look at what actually happens in the kernel of your ESXi host when the virtual machine is getting access to the raw LAN. So this is the kernel, and this is a picture taken from the new vSphere 5 kernel, and you see things like Vi and Vasa already in it. This kernel, from top to bottom, will take you 2 milliseconds at the most. If it's going above 3 milliseconds, you definitely have a big problem in your environment. So 2 milliseconds for I/O to travel from the virtual machine to your platters, to your disks. And you see a lot of components in the kernel. And when you are going to take a deeper look into all the components that are available in the kernel, you see the physical raw device mapping, you see the virtual mode RDM, you see the regular VMDK on VMFS. Don't fall over. So you see the vStorage API, the adapter I/O scheduler, and the Linux emulation. I can tell you, the Linux emulation at the bottom and the vStorage API and the logical device I/O scheduler will take the most time to put the data on your platters, on your disks. The part above, you see the components like RDM, VMFS. It doesn't matter. It doesn't matter if your virtual machine is going through a raw device mapping or is going through a plain VMDK on a VMFS. So let's put the pudding to the proof, something like that, and let's see what we are going to do in our laboratory environment to debunk this myth. So our laboratory is created by a PX6 from iOmega, and I called Chad Sackett and I said, hey, I'm a blogger, I want a PX6. Sure, Eric, here it is. And eventually the PX6 arrived at my home. And 2 weeks later, there was someone from UPS calling at the door. Eric, we want it back. So I had 2 weeks of fun with this device, but it's awesome. It has gigabit Ethernet. You can do iSCSI, you can do NFS. It has a great software in it, but I'm not promoting the box. I'm going to stop with that. It's in my environment, and it's eventually I created a virtual machine running Windows 2008 R2, and the virtual machine was configured with 4 gigabytes of memory and only had one virtual CPU, hardware version 8, and it was running on vSphere 5, the beta version, but it doesn't matter for performance. It was configured with a single 1 gigabit Ethernet connection, and I've used a Cisco 2960 switch with an MTU size of 1500. So this is a pretty normal configuration, and I created a virtual machine with 4 separate virtual disks, and all the virtual disks were pointing to another kind of storage. So there's one virtual disk that is a plain VMDK file on a VMFS. There's another virtual disk that is a raw device mapping based on virtual mode. There's another VMDK file that is a raw device mapping based on physical mode. And I even throw in the software iSCSI initiator from Microsoft. And the software iSCSI initiator can be installed in a Windows virtual machine. And I installed it in a Windows virtual machine just to see if it's as fast as a plain VMDK on a VMFS. So what you see here is it doesn't matter. So what should we do? Should we configure virtual machines with raw device mappings, or should we configure virtual machines with VMDKs on a plain VMFS? I think the benefits of a VMDK on a plain VMFS are far more greater and better and than if you are going to compare it with a normal RDM. So if we are looking at the Mythbusters, in the end, 1 gigabit iSCSI can only do 112 MB per second. It doesn't matter if you are using a raw device mapping, a software iSCSI initiator, or a plain VMDK on a VMFS. iSCSI gigabit has a limit, and the limit is 112 MB. So let's take a look at the other reasons why we should use VMDK over raw device mappings. VMFS data stores are designed to host large files. They have special things like block tracking, like snapshots, and they are performing very good, and you don't lose any I/O performance on hosting VMDK files on a VMFS. VMFS is optimized for storing those large files, but if you want to use an RDM, you have to have a good reason for it. For instance, if you are doing SAN snapshotting, and your SAN software is not aware that your virtual machine is going into snapshot, then you will have a virtual machine that is not, how they call it, crash consistent. So the SAN snapshot is taken, the virtual machine is not aware of the fact that the snapshot is made, and the virtual machine will crash on a reboot because there was still data in the buffers and the buffers were not committed to the disk. So that's one reason. With the other SANs, you don't have snapshot-aware SANs, so you might want to put it on a SAN. Another reason can be that you are using clustering between physical and virtual machines, Microsoft clustering. So if you're doing clustering between physical and virtual machines, you need a role device mapping based on physical. Your Microsoft physical server doesn't know what a VMFS or a VMDK is. So you're forced to use a role device mapping. You cannot escape that. The biggest reason these days why I should use a role device mapping is that VMFS5 is awesome. VMFS5 is able to create volumes greater than 2 terabytes. Yes, it's true. In the VMFS 3 days, we were bound to a maximum size of a VMS volume of 2 terabytes, and we had to add extents, and we could add extents up to 32, so we could get a volume of 64 terabytes, but if you lose one extent, you lose your complete data store, and VMFS5 is able to address 64 terabytes. So if you want to give a virtual machine a very large disk for a file server, for an Oracle database, for an SQL database, then you can give your virtual machine a volume that is above 2 terabytes. You can even go to 64 terabytes if you want to. So those are the use cases for role device mapping. Do it for functionality, but not for speed. You won't get a faster environment if you are using RDMs. Okay. Let's go to myth number 2. Change block tracking.
Yep. So before I start with this, I just want to see hands up if anyone here is using change block tracking in your environment. You that raised your hands, can you answer if have any one of you seen performance degradation after enable it? Oh, no hands. Good. Well, I'm going to talk about the change block tracking. It's a feature that the backup vendors are using in order to find changes faster, and it wasn't. So when I started looking at this myth, it was very hard to find something that described the overhead. Old papers, old documentations only say it has a small amount of overhead, but they couldn't find any numbers on it. So that was this caught my interest. So first of all, what is change block tracking? It's a driver that is inside VM kernel, and its purpose is to identify change blocks within virtual disks. So the upside of using change block tracking is that you can reduce backup windows. If you look at back in the days when this wasn't available, the backup applications had to first snapshot a VM and then scan the virtual disk to identify the changes, compare it to a block map, and back up those changes. And that scanning process took time. It could take up to 60 minutes just to scan and identify those changes. And that entire scanning process is eliminated by this change block tracking process. So backup windows are reduced. It goes for both for full backups. Not so many people know about that. It's actually because of when the backup software reads the full image, change block tracking will remove the unallocated blocks from that VMDK read. So the full backup will be faster. But it's very obvious for incremental and differential backups that when the backup application snapshots the VM, query the change block tracking API from the point in time where the snapshots were taken, and from that time to previous snapshots were taken, and the API just returns those blocks between those time frames. So it's very quick. It reduces backup windows up to 2 or 4 or 5, 6 times, and it also helps reducing resources on the hosts. In order to enable this, you will need vSphere 4 or later, and also the VM itself needs to have virtual hardware version 7 and above. There are some limitations, as Eric showed here on the physical raw device mappings earlier. Changebook tracking, as you also can see on the slides, it's there it is, resides up in that layer, and it can only track virtual RDMs and regular VMDKs on regular VMDK files. And it works across NFS and VMFS. This is enabled through vCenter manually, or you can use your backup application to enable it through there. And there is also various Power CLI scripts that you can enable it for all virtual machines in a given cluster, for example. So by all this said, it should be a no-brainer to use this. The only reason why you shouldn't use this if your backup application doesn't support changebook tracking. So back over to the overhead I was talking about, and this was actually, I think, the hardest to find for this presentation. Has never been documented anywhere. I had to find some friends at VMware that put me in contact with the creator of the changebook tracking API. And I divided the overhead in 3 different categories. First, memory. As you can see on the previous slide, the changebook tracking driver, it resides in memory in VM kernel. And depending on the size of the virtual disk your virtual machine have, it will need a certain amount of memory to capture the blocks that changes. And the maximum disk size for a virtual machine is 2 terabyte, and that will need 256 kilobyte extra memory. And maybe a regular VM uses 100 gigabytes of disk space, then you would need an extra 125 kilobyte on your disk array. So it's a very small amount of disks needed for this. Same goes for CPU. The changebook tracking driver that runs on the host in memory, when something changes on disks, the driver will capture it, and it will only turn on a bitmap in memory. So that's also very, very small, and it's almost impossible to see any overheads from that. When it comes to storage, it's twofold. First of all, you need some extra space on your data store. So when you enable changebook tracking on a virtual machine, you will see a CTK or a change tracking file that is created. It's a static file, uses approximately 0.5 megabyte per 10 gig VMDK file. So for each of your VMDK files, you will see an additional CTK file, and this is a static file that doesn't grow. It will be created up front when changebook tracking is enabled, and it won't grow over time. So the memory, the driver, the changebook tracking driver in memory, it will flash down the bitmaps from memory when disk gets closed and when a snapshot is removed. So it will write down all that in memory down to the CTK file. And depending on the size of your virtual disks, the driver will be different in size. So, but you can see on the memory size there, it's a very, very small amount of disk reads that will go, or disk writes that will go down to the data store. So the test I was using, we're running 2 different virtual machines, one with changebook tracking enabled and one with disabled. I was trying to look at CPU, memory, and storage to see if I can measure this. And the only thing I noticed, or that I could actually measure, were the overhead in storage space. So the change tracking file I could see in the data store, and it resides in the same data store that your VMDK file is in. Also, I did some performance tests with disk testing tools, and what I could see here was no negative impact of throughput on the different tests. I ran it multiple times, and it always came up with the same results for both changeblock tracking disabled and enabled. So in summary, this is another myth that has been busted. The changeblock tracking overhead is very, very small. It provides lots of good benefits when it comes to reducing the backup window and also reducing the host resources needed. So I would say it's a no-brainer. Always use changeblock tracking if your backup application supports it.
Okay, thanks, Matthias. Great bust. Thank you. So I have a question for you. Who of you attended about 4 or 5 years ago their first install, configure, and manage training and had a lab with 3 types of resource pools, low, medium, and high, and who is still using those resource pools? Yes, I see some hands. Okay. So do you use resource pools to group your virtual machines? To make them look nice, for cosmetic reasons? I want to see some hands. Yeah? Okay, cool. Okay. So there is a situation where contention can create some horrible scenarios if you are using resource pools for fun. Don't use resource pools for fun. They can be dangerous. And in this myth, I'm going to explain to you why you should resource pools, or maybe you should stay away from them. So first, let's take a look at some resource settings. This is the stuff you don't see at Frank Denneman's session. He's only talking about virtual machines and resource pools, but we have something else in our environment, and it's called VApps. What the hell is a VApp? A VApp is used by most of you to be able to configure the start order of your virtual machines. Isn't that true? But the VApp will be the future of our cloud computing environment, because a VApp can do much more. A VApp can get access to IP addresses, and it can give IP addresses to the virtual machines within the VApp. The VApp can be used to update the virtual machines within the VApp, and the VApp can do much, much more. You see sometimes VApps in vSphere environments, and people are saying, I put my SQL server and I put my virtual center server in the VApp, because the virtual center server has to start first, and then the SQL server has to start first, and then the virtual center server will start. Otherwise, the servers won't run. It's a valid reason to use a VApp, but keep in mind that if you are configuring a VApp with only 2 virtual machines, a VApp will get the same amount of shares as a normal resource pool. So let's take a look at those 3 things: CPUs, shares, reservations, and limits. The VApp is dangerous. If you are using the VApp, it will get a default amount of shares of 4,000, and it will be equal to a virtual machine with 4 virtual CPUs. A resource pool will also get 4,000 shares and will be equal to a virtual machine with 4 virtual CPUs. A virtual machine will get the amount of shares based on the amount of virtual CPUs. So I know who went to the keynote this morning from Steve Harrods? Yeah? Who is going to score a Monster VM shirt? Yes? Okay. So a Monster VM is a virtual machine with 32 virtual CPUs. Ooh, that's scary. A virtual machine with 32 virtual CPUs. Should it get 32,000 shares? I think so, if you calculate it. So a virtual machine with 32 virtual CPUs is a Monster VM for my resource pools. Okay, so let's take a look. Oh, one other thing. If you are configuring settings on a virtual machine, don't even think about touching limits and reservations. If you are going to configure a limit on a virtual machine and the amount of memory configured by the limit is beneath or under the amount of configured memory for your virtual machine, so the virtual DIMMs you have put in the virtual machine when you created it, you will create ballooning, compression, and in the end your virtual machine will swap. I see a lot of clients which are experiencing ballooning problems, and there is plenty of physical memory available. So what happened? There was not one nasty administrator who put in a limit on a virtual machine just because some project leader was demanding all the physical memory for himself. No, once there was a guy who created a template, and the template was created with 512 MB. And if you move a template from one host to the other, the 512 MB will be the limit of that template. There was a little error in one of the prior versions of VMware, and limits could be introduced in virtual machines without knowing, without even seeing it. So if you are rolling out a virtual machine based on a template which already has a limit, and you are going to use the virtual machine, and you are going to hire the amount of memory of the virtual machine, and you will give it, for instance, 1 gigabyte, what will you see? 512 MB of pure ballooning. And there's enough memory available in your environment. If you see a client, or if you see your own environment, and you are experiencing ballooning problems, go to your virtual machine tab, look at it if there are any limits configured, and throw them all away. The other thing is reservation on a virtual machine. It will hurt the performance of your complete environment. So don't listen to the project leader that says, our budget was for 4 gigabytes and we only get 2 gigabytes. Yes, because you're only using 2 gigabytes. But we have bought 4 gigabytes and we want 4 gigabytes. Put in a reservation at 4 gigabytes. Don't do it. What will happen is when you start a virtual machine with, for instance, Windows, Windows will zero out all the memory before the OS is started. Once your kernel signals that all the memory is touched and the virtual machine has a reservation, the reservation is claimed and will be secured for that virtual machine. So even though the virtual machine is never going to use 4 gigabytes, your virtual machine will still keep those 4 gigabytes occupied. Don't configure reservations, don't configure limits. So let's go further with our myth-busting session. What you see here is the sibling CPU shares value. And sibling means on the same level, brother and sister. So don't mix oranges and apples and pears and whatever. Don't make a fruit salad of your inventory because you're gonna get hurt. What you see right here is a typical situation I see at a lot of clients. They are creating resource pools. Well, they're default. I didn't do anything about the resource pools. Yes, but it got 4,000 shares. They are creating VApps. Well, the VApps are also default. I only configured the startup order for the virtual machines. That doesn't hurt my performance, does it? They are creating virtual machines. And in this example, I created a virtual machine with 4 virtual CPUs. But after the keynote from Scott this morning, or Steve this morning, I'm going to create monster VMs with 32 virtual CPUs. And you will see that every virtual machine with 32 virtual CPUs will get 32,000 shares. I want to see those virtual machines in the resource pool when you are powering on that virtual machine. So believe me, understand me right. This situation, so on the percentage column, is only effective when there is resource contention. When there is no resource contention, you don't have any problems. So the shares will be used when virtual machines are fighting for performance. Not if everything is running fine and smoothly. And so you will notice this when you are in trouble, when one of your hosts goes down, or there is some vCloud directed guy who is creating a new organization or something else. After big changes, you will get contention. This is for CPU. Let's take a look at memory. If you are going to look at the memory shares value, you will see a VApp with 163,000 shares. It's the default value for a VApp. And it's the same value as the value which is configured default for a resource pool. So a resource pool will get 163,000 shares, and a VApp will get 163,000 shares. The virtual machine will get the amount of memory multiplied by 10. So this is much more fair. A virtual machine is not able to drive away resource pools or to suck out VApps. Virtual machines are lower priority in this case. But still, you need to take into account that the percentage column on the right is your worst case scenario. So if there is memory contention, then the virtual machines and the resource pools will be configured or will get that amount of physical memory and start ballooning or start swapping or start compression. What's the biggest problem in your environment? CPU or memory? Memory. Can I see some hands from memory? Okay. We have lots of CPU. We don't care about CPU. But our biggest problem is memory. Maybe that's the reason why VMware created a license policy based on memory. Okay, so memory is the culprit. So keep that in mind. Let's take a look at our laboratory environment. In this case, I'm doing it with CPU, but you can also do it with memory. You will see 4 servers. They're They are not from a particular vendor. They hold 6 gigahertz of CPU power. And who went to a vendor party last night? No vendor parties? Oh, I see a few. Would you rather go to a vendor party with lots of people and lots of beer? Or would you rather go to a vendor party with a few people and enough beer? I think the last one isn't that cool, because a few people on a party, where's the fun in that? So let's go to the party with the beer and the people, but you will be in a resource pool with a lot of virtual machines. And if you are going to take a look at this picture, you will see worst case scenario. Everything is configured default, so the virtual machine has 4 virtual CPUs, and it's sibling with the resource pools and the VApp, and the virtual machine will get an amount of 4,000 shares. The virtual machine on its own will get 6 gigahertz. 6 gigahertz for one single virtual machine, because it's sibling on the same level as my VApp and my resource pools. The second resource pool has 4,000 shares, will get 6 gigahertz, and there are 8 virtual machines in it. So that means that every virtual machine in that resource pool will get 0.75 gigahertz. The third resource pool is the party resource pool, the vendor party resource pool. It will get 6 gigahertz. It has 4,000 shares, but there are 12 virtual machines in it. So you don't get a lot of beer. Maybe that's okay, because you have to go to the VMworld the next day, and don't skip the keynote this time. Every virtual machine will get a half gigahertz. And then the VApp. The VApp, in most cases, will not contain as much virtual machines as a normal resource pool. The VApp is one application, multi-tier, a database, a web server, some backend software, 4 or 5 virtual machines at the most. So a VApp is very scary, because a VApp holds very less virtual machines, in this case 4, but it still will get the same amount of shares as a resource pool does. So 4 virtual machines eating up 6 gigahertz will mean 1.5 gigahertz for those 4 virtual machines. This only goes when there is contention. Shares are only used when virtual machines are fighting for resources. But do your math. Otherwise, if you will get contention, for reason, whatever, you will run into problems. So the myth is busted. If you want to use resource pools, do your math. If you want to group virtual machines in a container, use the blue folders. And the blue folders can be found under virtual machines and templates. And those folders can also be configured with security. Those folders can also show you the performance of a group of virtual machines. But those folders are not used to configure resources for a group of virtual machines. So if you want to group virtual machines for cosmetic reasons, because they are from a client or a department within your company, or from a test or a production environment, use the blue folders. Don't put them in resource pools. I would rather put every single virtual machine in a root of my DRS cluster than create resource pools. You are forced to create resource pools if you are introducing the vCloud director, because the vCloud director is depending on resource pools, and that's where your SLA is configured. That's where the amount of CPU and memory resources are configured for a particular organization. But then you have to get all your virtual machines out of the root and put them in another resource pools. Don't let virtual machines, VApps and resource pools sibling on the same level. There was a question yesterday at Frank Denneman's session, and the guy said, well, I configured my resource pools the right way, but when I'm provisioning for new virtual machines, I put all those virtual machines in the root, and it can't harm, does it? Or what must I do? Must I put all those virtual machines in a resource pool within a resource pool? I think you're making it very complicated then, but try to put the same inventory types on the sibling level. So resource pools among each other, VApps among each other, virtual machines among each other. Otherwise, you're not able to configure the shares the right way. On the other hand, if you want to be the daredevil, and if you want to configure virtual machines and resource pools and VApps on the same level, it's possible, but you have to take into account that the number of virtual machines within a resource pool and within a VApp is eventually deciding the amount of shares. So there are some scripts which can be used to calculate the amount of shares based on the amount of virtual machines in the resource pool or VM, and then the resource pool is automatically configured with the correct value. But don't leave it default, otherwise you will run into problems when you are having contention. So if you want to use resource pools, do your math. If you want to group virtual machines, use the blue folders. And don't use VMs and VApps, orange and apples, on the same sibling level. Mythbusters. Matthias?
Okay, thank you, Eric.
Here's all yours.
So the final myth I'm going to talk about is comparing LSI SCSI controller with a paravirtualized SCSI controller. And first, and if I'm starting here, who in here have tried the paravirtualized SCSI device? Okay, any one of you guys using it as a standard template, in the standard template? Good. So first of all, I want to talk about what paravirtualized SCSI is. As you can see on the screen, it's a new SCSI controller that was introduced in VMware 4. At the introduction, lots of people were excited about this. Unfortunately, there were some, I would say, some drawbacks with it, some problems in the early stages of this driver. Those things were improved a lot in 4.1, and I would say today it's almost no problems at all with this driver. There are some limitations I will come to later. It was designed with two things in mind. First of all, performance. When VSP 4 was announced, they want to break some records when it comes to disk performance in order to virtualize high demanding workloads. So this device was introduced for performance, and according to the tests they did, it could increase the performance up to 12%. And the other side of this driver is also that it uses less resources to produce, or in order to serve that high demand workload, up to 18% decrease of CPU resources needed on the ESX host. That means that you can run more VMs on the same host so that you can increase the VM density. It supports the most common operating systems: Windows 2003 and above, Red Hat Linux, SUSE Linux, Ubuntu Linux, and a bunch of others. It's not the full supported list that you can run on VMware, but I would say it serves most of the VMs that are running out there. And the same for this, it needs virtual hardware version 7 and later. So in this test lab, I ran two different virtual machines. The first one with LSI SCSI controller, which is the default controller when you create a Windows virtual machine. And the second one I configured manually with the paravirtualized SCSI controller. I ran a series of different disk testing tools, and in my case here, I didn't see any difference in disk performance. And the reason for that is the disk subsystem I was using couldn't handle the high workload, didn't benefit from the benefits of the paravirtualized SCSI controller. But if you have a SAN environment with more spindles, more capable of performing with high workloads, you will see the performance difference then. But interestingly enough, I saw the difference in CPU utilization, as you can see on this picture down there, comparing LSI to the left and paravirtualized controller to the right. And I saw approximately 20% decrease of host resources. So you can imagine with the host that we have today, it's not uncommon that you have up to 50 or 100 virtual machines on a single host. And if you multiply all those cycles that you can save on each virtual machine, you will actually be able to run more virtual machines based on that CPU perspective. As a kind of a side note, but I think it's important to point out, in this test I was using Windows 2003. By default, Windows 2003 and earlier doesn't align the disk subsystem. So when you create a disk and format it with NTFS, the starting offset will not be at the default. The default will be at an odd starting position. So I used disk part when I created the disk and set the starting offset to 64K, which is the best practice. If I only created the disk through disk admin in Windows, I saw a 20% decrease in performance when it comes to throughput and IOPS. So that's one thing that's very important to know about, that disk alignment can really kill performance. And if you're looking to maximize performance, you should definitely make sure your VMs are aligned. So again, this was also busted. Paravirtualized SCSI, it provides equal or faster performance compared to LSI SCSI. We saw it uses less host resources than the LSI SCSI controller. It used to have more limitations. Some of the limitations where it didn't support booting from a paravirtualized SCSI controller. There were problems with VMs that had low demanding workloads that were actually performing worse with this controller, and a couple of other drawbacks as well, but all those has been removed. So my question is, why aren't we using this fabulous SCSI controller? And I think it's all come down to it takes time to change behavioral. The LSI SCSI is still the default disk controller, and the reason for that is it has been around for a long time, it has been tuned, people are comfortable with it, and it supports the full, all kinds of operating systems. So it's kind of for ease of use, I think. But I would encourage you all to start looking at paravirtualized SCSI controller, make it part of so kind of your standard templates, because if you deploy your LSI SCSI controller and later on you find out that this is a high demanding workload, you have to shut down the virtual machine, reconfigure. It takes time, outage, and lots of efforts to do it. So the recommendation I would say is make it part of your standard template. And questions I've got previously on this is, should I change this for all my existing virtual machines? And I wouldn't recommend you doing that. It takes a lot of work to do that. I would identify the top performance virtual machines that demands the most from your disk subsystem and focus on them and fix them. The other ones that are not so high disk workloads, I wouldn't take the efforts to fix.
Well, that's a great myth.
So, the summary, Eric.
Yeah, the summary. So, do you agree with me that VMFS is always better than raw device mappings? Who agrees? Oh, only a few. Okay,
oh man,
only a few. You guys are hungry or something, or so I think you should use raw device mappings if you want to give a virtual machine 64 terabytes. Wouldn't that be cool? If you have a large file server or a big Oracle database running in your virtual machine with 32 virtual CPUs and 64 terabytes, please give me a call. I can create a real cool article on my website, ntpro.nl, and I would love to get some screenshots of your configuration. So VMFS is better than raw device mappings. Yes, use raw device mappings only for functionality, not for speed. So that's myth number one, busted.
Change bug tracking, as I showed you guys, it has very little overhead. It's a no-brainer. Use it, but only if your backup application supports it.
Okay, so if you want to play with fire and put virtual machines, VApps and resource pools on the same sibling level in the root of your DRS cluster, do your math and decide how many shares you want to give to each item in your root resource pool. So Mythbusters, use the blue folders, don't use resource pools.
Paravirtualized SCSI, start look at that. It provides better throughput with less resources required. And I think that's also a no-brainer. Start using that also. It's good stuff.
Okay, I want to thank you all. If you have any questions, please ask them later on. And have a good lunch. And I hope to see you back soon. Thank you.
If you have questions, you can either, I think it's best if you do them in the microphone or
come to the podium.
Okay, come to the podium and we'll take questions here. Thank you very much.